Hey everyone, welcome to the Unhandled Exception podcast. I'm Dan Clark and this is episode number 81. So we are slowly making our way to 100 episodes, which is quite exciting. And today I'm joined by Jeffrey Palermo, the host of the Azure and DevOps podcast, founder and chief architect of ClearMeasure, a software architecture and engineering company, a long-time Microsoft MVP, a tech speaker, a book author, and much, much more. So welcome to the show. I'm actually a big fan of your podcast, so it is an honor to have you on.
Oh, it's my pleasure to be here. Thanks so much.
So before we start, could you just give yourself a quick introduction to listeners and tell us a bit about what you do?
Sure. I started programming when I was 15. That was in 1995, I think. And at the time, the internet was super, super young. So I was programming HTML. I was the only kid in high school with a website on the internet, or the only kid that had an email address. That was very nascent. And I cut my teeth. My first programming job when I was 18, right out of high school, was building really, really early websites when you had to build one for Internet Explorer 2 and then a separate one for Netscape 3 because there was no compatibility. And that led me into the predecessor of Microsoft Active Server Pages, which was the Internet Database Connector technology. It had the code nugget, the less than %. And then Active Server Pages kind of inherited that technology and kept it going forward. And Microsoft had just acquired what would become SQL Server, the database server. And then I kind of kept with it and done a whole lot of projects along the way. In 2007, I switched from working in internal projects to consulting. And I've been working in a consulting fashion ever since 2006, doing projects based on contract and delivering software and advising. And now I have a lot of fun because we're doing that here at ClearMeasure, and my role is the chief architect and looking at the industry and what kind of technologies and trends and patterns and pointing the direction, but also setting up all of our people so that they can be as successful as possible.
I always love hearing people that have been in the industry for quite some time, just the old technologies and the starting. It just brings back so many memories. It's like what you mentioned about email. I remember reading a magazine about someone saying that they would log in the morning to the bulletin board system to check, and they explain what was kind of like an email kind of concept. And I remember reading that thinking, oh, that's amazing. You can just check your emails. And so, I don't know that it was called emails at the time. I really can't remember. But that concept, and now look at what we've got today, that journey in not that many years. It's quite insane.
Well, it's been a journey of places to go to get answers. So we're all used to doing an internet search. If I don't remember a particular API, or how do I use this library, or I've got a problem, does anybody else have that problem that I need to solve? And I remember in the 90s, it was Usenet and news groups, and there were specific readers to get into NNTP protocol. And then the news groups and Usenet, it's almost like a huge swath of it got acquired by Google early on, and it became the predecessor of Google Groups. But Deja News was an aggregator, and then they got acquired by Google. And then Google Groups were big. And then fast forward, Reddit and Stack Overflow became big as places to get answers where people were posting problems. And now everybody is just asking an AI tool, hey, what's the syntax for this? Or how do I use it? And it's kind of like Google search has just, another era in searching for stuff.
Yeah, we're both sounding very old to the younger listeners right now.
I mean, you have to know history. I mean, my programming started in 1995, but the things that I've learned about how computing was in the 50s and the 60s and the 70s and the 80s have really helped me not make some fresh mistakes from things that were solved back then.
I used to love it. I got into computing because my dad brought home computers from his work, and he used to bring back like the VIC-20 and the BBC Micro, and so I can then tinkered and played with it, and that's kind of like the start of my journey. So it's always good to reminisce.
Right, absolutely.
And now we've got AI, so we're in the next big cycle. Can I mention about, obviously you do your architect forum?
Yeah.
Obviously we had one earlier this week. I've only been to 2 now, and you've been covering a lot in AI stuff, and you demoed Cursor, which was, well, obviously we can get into a bit later maybe, but it's just quite fascinating to join that forum. I should have joined it sooner, to be honest, and just chat and geek out with like-minded people.
Yeah, so the reason we started is because It's kind of like a hole in professional development. You can go on YouTube and the internet, and if I need to program something, I can find videos and all kinds of resources to learn any particular new library. Or if I'm trying to figure out what the new features of C# are or .NET 10 that just came out, yeah, I just go on and there's YouTube videos and blog posts and all kinds of stuff. And I can learn any technical thing just by doing an internet search. What about for software architects? When your role is to lead a group of software engineers to accomplish something bigger, how do architects go about professional development? How do architects learn how to do a better job at that? And I use the word architect as the term of the person who needs to take a group of software engineers and kind of lead them and point the way and accomplish an objective. And of course, that goes to making sure we have a good shape of the software system that we are building or growing. And that also goes to designing the elements of the project that has any hope of yielding a system of that shape. It also goes to crafting the shape of the team that is capable of delivering that project. And I use the term architect because I think that's the best term of software engineering leaders.
If it's okay with you, I can include a link to the show notes. I don't know whether you actually want.
Absolutely. Yeah. And it's a peer group. It's kind of like an online user group. I just facilitate it. I try to get the conversation started, and it's full of smart and capable and experienced software architects who are each leading their own software engineering teams. And we talk about the topics that are relevant for the time.
Yeah, I do love the way that everyone has to have webcams on, has to be engaged, and that's like, even if someone comes in with the webcam off and microphone muted, it's kind of like, no, so you've got to leave, set yourself up for next time, and it just makes sure that everyone's engaged. So I love it. But we should probably get on with the main topic. But before we do, which is, in fact, we've not said what the topic is, AI-driven development and DevOps. I've just got a few small mentions for the listeners. Firstly, the podcast has its own Discord community. So if you head over to the website unhandledexceptionpodcast.com, you'll see a big Discord link there. And also, I have a monthly newsletter where I send out handpicked developer news items from the past month. It also includes a dev tip and a dev comic pick, as well as podcast updates about the show. So it's basically a great way to keep up to date with what's going on in software development. If you want to sign up, there's a subscribe link on the podcast website. And lastly, a quick reminder that this podcast is brought to you by Everstack, which is my own company providing software development and consultation services. For more information, visit everstack.com. And links to all the things I've just mentioned and all my socials are available on my personal website, danclark.com. Right, so let's dig in. So obviously AI-driven development and DevOps is quite a big, broad and huge topic. So where's the best place for us to start?
Well, I end up talking quite a bit about how to think about AI and the different frames of mind that we can have, because certainly in 2022, everybody started using ChatGPT and figuring out, oh, it can draft sentences. Fantastic. And now we have Copilot and Cursor and Claude and all these tools that can write code. And so the natural question is, wait a minute. So can the computer just write the code? And so there's some buckets that I think are appropriate, some categories of thought, so that we can, when we talk about AI, we talk about the same thing. So certainly there's just end user tools like Microsoft 365 Copilot and all your files that are in SharePoint and OneDrive storage. That's useful. And ChatGPT, that's useful. And AI is getting embedded everywhere. Okay, that's one category. Another category is embedding LLM usage in the software so that the software can have a interesting feature that uses AI, from either an embedded chatbot or even a embedded agent that's just running in a background job where you have it do some fuzzy logic that's beyond what maybe a rules engine just design pattern might be able to do. So that's another category. The third category is being able to delegate some software development, delegate a software feature to the computer. And that's what I think is that's really interesting for me. And a lot of people are trying to figure out how to make that come true. We see it coming, but the question is, okay, how does it work and how does it fit in? There's been some studies that were in the Q4 of 2024, before Copilot even went GA in May of 25, where Cursor was kind of like the first mover. It really was, but it didn't have full agent mode. And so people who were using it to write code were copying and pasting code from the screen and putting it in. And there was a study of productivity, and productivity incrementally went up, but the amount of time spent reviewing and fixing code also went up. And so it really wasn't a slam dunk to say, oh, we should be doing it this way. It was a mixed bag. And I think that that's key, the rework. If we really are going to take a software feature and be able to delegate it to the computer, then when the computer reports a status of complete, we need to be able to trust that status. It actually needs to be able to be complete. And we know that a pull request of a branch in a Git repository is a fantastic way to say, okay, here's a unit of enhancement in a software application, and here's a pull request. And if I'm going to merge the code changes from that pull request into my master branch, then the build on that feature branch should be as stable as the master branch is now. It shouldn't have broken anything. And the only question I should have to ask is this new feature complete? I shouldn't be having to ask, is something else broken? Did we make a mistake here? Because then that feature branch is a total waste of time. If I assign to one of my engineers to do a new feature and there's a branch and I ever have to ask the question, is the software broken? He's not doing his job. And so if we're going to delegate to the computer, we have to maintain that standard. And so our DevOps environment has to be complete enough so that the tooling, when it reports complete, it means complete and stable. That has to be part of that definition.
One thing that jumps to mind to me there is the importance of having good test coverage. Otherwise, it can't verify that you've not broken anything. A lot of companies and projects don't have that coverage, so that becomes tricky in the first place. But then I guess we can also leverage AI to help with that, I guess.
Well, you can, but what you said is important, that it's required. A complete DevOps environment is a prerequisite for AI-driven development. And what we know about DevOps environments are they are highly automated. Not only are we doing just a basic compile and copying files over to environments and deploying it, but a complete DevOps environment has a whole lot of automation that is checking absolutely everything necessary to give that answer. Does the system work? Does every feature continue to work? Does it still deploy appropriately? Do all the components of this deployed application still start up properly? When they start up, do they still do what they've always done, or are they now throwing errors? So the DevOps environment is inherently highly automated, and the easy stuff is just compile and deploy. The value is in checking, testing, and validating absolutely everything about that application, so we have confidence that we can go forward and deploy it progressively down our environment pipeline onto production.
Just taking a few of the things you said then, and you did mention like agent mode when talking about Cursor. I've not used Cursor that much, but I've used agent mode quite a bit in VS Code. Just in case some of the listeners haven't actually even delved that far, one thing I've found when, especially more recently with GitHub Copilot in VS Code, is it's doing a lot of the things automatically that you just said. So like it will do a feature or make a change, then it will run like .NET build. It'll look at the output. If it fails to compile, it will look at the errors and then on its own just continue working, fixing the errors. Then it'll try and run the tests. So I guess I just wanted to, for the listeners that haven't actually delved with agents in like GitHub Copilot or whatever it is, it's come along a long way and it's so powerful. It's not, as you say, a case of ChatGPT, then copy some code, which, as you said, for a long time, that's how you did things, like when ChatGPT first became a thing. Another thing you mentioned was like delegating, which by that, are you talking about things like in GitHub where you can assign an issue to Copilot and it just be in the cloud?
Good point. Within the category of using AI for software development, there's two usage modes. One is so that I can develop a feature and just be quicker about it, using Copilot in Visual Studio and doing some inline searches or asking for some changes. If I don't remember a certain PowerShell or a certain API, it's like, okay, do that for me and then check it and make sure that it is what I'm expecting. And so kind of integrating those Stack Overflow or would-be Google searches directly in there. That is the interactive, monitored usage of Copilot. The other means is literally delegating it to the computer and just setting it aside and then coming back whenever the status is reporting complete.
I've done that a few times where, like the example I gave with GitHub and assigning an issue to Copilot and doing that just before a meeting, and then knowing that you'll finish the meeting and check your emails and you'll have PRs in your emails with the work probably mostly done. I think that's just such a different paradigm shift. It's quite interesting. It's kind of like where with productivity and stuff, it's always in the past, it's like one of the main things has been focus on one thing. Like humans can't multitask, just like focus on one thing.
Yeah.
But with this, it's almost like encouraging us to almost be like an AI agent manager or orchestrator where you're delegating, then doing something else, leaving that in the background. So you're kind of like context switching by delegating. So I'm finding I'm doing that a lot more.
So a lot of software engineers have learned the concept of recursion, recursive functions. And I think we're doing a little bit here in the software industry where for a long time we have built software systems and our level of abstraction has been to create libraries that just encapsulate things and then we reuse that. Well, now we're moving into the era where we are designing software systems that build software features. And I didn't say designing software systems that build software systems. We're not to that point yet. We're designing software systems that can build features in existing software systems. And so if we delegate to the computer and then set it aside, well, now we've started a program, the program is running, and we hope that the outcome is going to be a enhancement to the software that we're happy with. And so in order to do that, well, that's automation, but that's what we do. Programmers have always caused computers to automate certain tasks that are useful. Well, now the task that's useful is building new software features. So if I build that, then I can give the easy stuff to the computer and then I can focus on the more tricky things or maybe the things that are being done for the first time in this particular software system. But if I've done some type of report, 10 times before, well, we know how to do reports. Okay, now we need another report, or we need to slice the report by a different dimension. Okay, that's easy. I should be able to delegate the easy things to the computer.
Yeah, I kind of do the opposite. I delegate the hard things to the computer so I don't have to.
Well, okay, you could say the hard things are maybe things that I don't remember off the top of my head. And that's great for the interactive mode where, hey, I'm going to have to do a Google search. But if I want to delegate it to the computer and not watch it, if I just want to say go, then I have to specify what concept that it needs to satisfy and make those design decisions. I have to think about and specify how someone is going to use that new feature, the user experience. I have to specify the technical details or patterns or libraries that I want used. So that's the technical design decisions. And I have to specify the definition of done. What should be in scope? What should be out of scope? Maybe a few bulleted full system test scenarios. When this feature is complete, I ought to be able to go through this path, and then it works this way. I ought to be able to go through a different path. And armed with that, these coding tools like Copilot and the Sonnet 4.5 model has all of the context necessary to actually come out the other end. If I don't provide those design decisions, it doesn't, there's not enough information. And then there's guessing based on who knows what in the large language model. And people typically don't have a lot of luck with that because, it just ends up being throwaway.
It's interesting why you say it's just automation and we've always done that. I guess the key difference is that in the past it's been quite deterministic, where with AI it's kind of, you don't know what it's going to create. It's like if you ask it to create a UI of the same spec, you probably end up with totally different UIs. And in a way it's good. I remember when you were showing Cursor and you had multiple agents working on the same job. So if you do that and it comes up with different UIs, you can actually pick which one you like the best. And you've not lost much time. You've not lost time really of your own time. It's just compute of the things you're going to throw away. But if you had spent weeks working on that, then you don't want to throw it away, even if you're not quite sure of it. But it's just being able to run these things in parallel, almost like look at it and A/B test it in your own mind. Which one do I want? Which one's better? And that kind of thing. I think it's quite fascinating.
Yeah.
One thing I found, because I used to do I did quite a lot of blogging. I need to get back into blogging, and I've in the past written lots of documentation. I've done a lot of writing, and I feel, and at the time I didn't know it, but the skills I learned by learning to write are now paying dividends with writing prompts and stuff.
Mm-hmm.
Because I feel that being able to articulate myself when I'm writing a spec, like in a prompt file, that makes such a difference. Like I had quite an interesting one yesterday where, so at my main client, we use Kubernetes, and for local development, we port forward to it's kind of a microservice kind of architecture, but for the service we're working on at the moment, we port forward all the other services, so it's just in a dev cluster.
Yeah.
So we don't have to spin them all up locally. And we were using, I won't mention the name, but we were using an open source tool to manage that. You import like a JSON file with a list of these port forwards, and it does the port forwarding for you. But it was very flaky. We had to use a specific version. The latest version wouldn't work and everything. So I thought, I'm just going to write one. It's like all it needs to do is run a command, like the kubectl port forward command against each of the ports we want to forward. So it can't be that hard. So I just opened a markdown file, wrote a spec, and even put things in like use Spectre Console to make it visually appealing.
Yeah.
But I wrote all the requirements, but I wanted it to look good as well. And for listeners, I'll put a link in the show notes for Spectre Console. It's basically, if you're writing a console app in .NET, check it out. It's awesome. There's lots of like components and various things. It looks really good. But I told it to use that. First time, it nailed it.
Nice.
It was just, I ran it and it gave a nice Spectre Console table of all the port forwardings. It said source and target port. It said, so in the spec, I told it if it failed to connect, it had to reconnect automatically. So it had a column for how many retries and its status and all of that kind of thing and uptime. And that was literally just one shot from a prompt file. And I think just having the ability, as a software developer, engineer, whatever you want to call it now, having the ability to articulate yourself in text. I know you can talk to these things now, but whether it's talking to it or in text and specify that requirement and all the little education things you want, that is such a powerful skill, I think, moving forward. And I never realized it at the time when I was doing lots of writing in the past.
Yeah. Well, I mean, we have a word-based universe. I mean, even the DNA that defines the differences between me and you is a really long word. Or you could say as a sentence, however you want to phrase it, but it's language. It's not just a code, it's language. And our profession, I think, is forcibly being thrusted from being a art or a craft into an engineering discipline. Because if I continue saying, you know what, no, I want to handcraft every line of code, which we left that a long time ago when IntelliSense came. We don't handcraft every line. We hit the dot, we say, oh, that's what I want, tab, and so we have small completions. Or with ReSharper, I type FOR with a for each loop, and it kind of guesses the rest of it, and I hit tab. So we've been auto completing sections of code for a long time. It's just now the sections of code that we're able to auto complete are getting larger and larger and larger. And so in order to when the sections of code become larger, where I can't just glance at every line and say, do I like that exact line? We have to have a DevOps environment that is constantly validating quality. And if we're not going to hand inspect or visually inspect literally every line of code, then we have to have automation that inspects the important things about the code. And we have static analyzers for literally every type of code file, text file. So when it comes to the style of the code, okay, we have that covered. No problem. When it comes to if something is misspelled, we got that covered automatically. I mean, every aspect of the code that we would want out of it, there are tools that can verify it. We don't have to verify it manually with our own eyeballs.
So if we take a typical, like mentioned about DevOps and pipelines and things, if we take a typical pipeline, so like you push to Git, it then builds it, it runs unit tests, it deploys to an environment, maybe runs playwright tests or something. So that kind of pipeline where eventually it gets to production, which bits do you see AI fitting within that pipeline?
Right. Okay. So let me just go through the flow of what needs to happen if we want to delegate a feature to an AI tool and have a pull request come out the other end ready to be merged into master.
So we're starting even earlier than we're starting at the feature before any code's been written.
Yeah, before any code's been written. Well, you bring up a good point. We have to have enough of a design specification so that the AI tool has any hope of pattern matching and giving me what I want. And there's 4 types, I talked about them earlier, there's 4 types of design decisions that if I'm going to hand write the code anyway, I still have to make these 4 types of decisions. I have to do the conceptual requirements. What am I trying to accomplish? Then the UX design is, how is someone going to use this new software behavior? And then the technical design is, okay, what design patterns are appropriate for this, or what libraries do I need? Or are all the architectural elements that are in the code base sufficient for this new feature? Or is there something new where I need a new pattern? Those are technical design decisions. And then the fourth one is the definition of done, and that's the designing the test scenarios. If I have a login screen, then one path is good username, good password, I get logged in. Or another scenario is good username, bad password, I don't get logged in. And so however many pathways through the feature, well, those are test scenarios. And I would have to validate those manually. Well, if I'm going to validate it manually, well, then let the computer do it. Let me write an automated test and let's validate it automatically. So those 4 design decisions have to go into just the definition of a software feature, regardless if a person is going to do it or if we're going to try to delegate it to the computer. And so if I keep going from there, we can assign it to Copilot. If we're using GitHub, we certainly can assign it to Copilot there. Those tools, it's going to be running on Linux. And if your build chain is fully compatible with Linux, then you could take advantage of that. There's a lot of .NET software that has still some Windows dependencies in the build process. And so if you need to have the actual build run on a Windows computer or your computer, then Cursor and Claude CLI and Copilot and JetBrains Junie and OpenCode, those are all going to run and do everything on your own workstation, or the workstation that you want to run it on. You can put it on a VM or whatnot. If you're in GitHub and you tag it with the Claude helper, or you assign it to Copilot, those are going to be run on the hosted agents, which are going to be Linux. So it's just important to understand the environment that it's running on. But if I'm going to delegate it, first and foremost, it's going to create a feature branch. It's going to look at the Copilot instructions or the Claude.md or the agents.md file, the helper file of whatever tool you're using, and you're going to have to give it baseline instructions. You're going to have your development practices described in there, like create feature branches that are named in this pattern. And otherwise, it's just going to make up some weird feature branch that you're not going to be happy with, and it's going to be hard to find. You're going to have to specify where to find the private build, what the sequence is to do. You're going to have to specify, when done, submit a pull request, and the pull request should be named a certain thing. And right there, I said, if you don't have a complete DevOps environment, you're not going to be able to do this. A complete DevOps environment has to start with continuous integration. And continuous integration has 3 phases. It's the commit phase and the integration phase and the first deployment. And any listeners out there haven't read the 2006 continuous integration book that defined the pattern way back when, I'd encourage it. But the commit stage is on the local workstation, and the private build script is the most important tool there. And it answers the question, with the code that has been changed on this feature branch, has anything broken, or do I still have a stable code base? Because if I don't have a stable code base, it doesn't even make sense to commit the code to the branch because something's broken. Okay. And so if I commit and push to the feature branch, well, now on the server side, the integration build is what's next. And that takes the code that I just committed with code from teammates, because if somebody has merged to master in the meantime, that I need to back merge from master into my feature branch. So I have mixed code that I've changed and code that other people have changed. And the integration build answers the question, with this mix of code, do we still have a stable code base, or has something broken? Well, why? Because we're running unit tests and we're running component level integration tests. And if we don't have complete coverage with that, then we're just leaving surface area for bugs. But after our integration build succeeds, then there's still one more step before we can be confident about submitting a pull request. And that is answering the question, does this new build still deploy properly? Does it still start up properly? And does it still do everything that it did when running in a target environment? And that's why our DevOps environment on feature branches and master branch has to have the capability to take that build and do an automated deployment of that build and start up the app in a representative environment. It doesn't have to be the scale of production, but it has to be the same shape as production. You know, a downsized version. And with Azure, it's super easy to spin up those environments and whatnot. But we need to automatically deploy that build, start it up, and then run a full system acceptance test suite. And if it has a web application as part of it, Playwright is an amazing tool. It kind of replaced Selenium. Playwright's an amazing tool to click through the pages and go through those test scenarios that we specified to make sure that everything that the application used to do, it still does. And so whether it's Junie or Copilot or Cursor or Claude, kind of doesn't matter. They all work the same way. They will run the test suites, let the test suites run. If a test fails, well, that goes back into the context of the AI tool and it can be worked on. But the big advantage is that if we don't have a stable feature branch, we should never waste our time with a pull request that is posing as a pull request. A pull request is something that should be ready to be merged into master. And so we never want to get a pull request, that's out of the draft status that's saying, hey, I need to be reviewed, unless it's actually worth reviewing, which means it has to be stable code.
I find it kind of fascinating where the pipeline I described before, we've kind of now extended it to much. I know a lot of people don't like the term shift left, but we're kind of like making it even further left where potentially, obviously we want to review the PR, but there might be a time when we don't need to, especially if it's running all the tests and we've got AI, different models checking each other or something, that kind of thing, where potentially that whole pipeline we described starts at when you assign that GitHub issue. And the whole flow, you can just go to bed, leave it. It's assigning it to an agent or multiple agents. They're doing the work, creating a PR, then reviewing each other's code. Then it's going into the main branch, and then it does what I described, where it builds the actual proper artifact, runs the tests again, runs the Playwright tests and all that kind of thing, and it goes through to prod. And that happens when you go to bed and you've assigned it. You've literally just, here's an issue, assign it, and off you go. So it's kind of like, oh dear, what happens to our jobs? I'm joking. Now, obviously, I think developers...
Oh, there's plenty of work for us. Not worried about that.
Yeah, I think there's going to be there's going to be two sides. We're going to be architects for agents, as we were describing before. But I think also AI being in the wrong hands for people writing software that doesn't have our background, doesn't have the background of knowing what to look for in these security things. And,
well, I mean, to be fair, we were all young. I mean, I wrote software. I had no business in writing early in my career. I think that's just what happens.
It is, but there's going to be a lot more of it, as in the
Sure.
amount of stuff. Like anyone can just tell AI to create an app and then it's going to appear, and it's going to look good as well.
Yeah.
That's the problem. It's going to look really genuine and good.
Yeah, it will.
But I'm aware that you did say that you've got a hard stop on the hour and you've got another podcast recording for your podcast. So we really do need to wrap up because it's just a few minutes away. Before we wrap up, shall we quickly do dev tips?
Absolutely. So my tip would be about running command line AI tools. So Copilot is great in Visual Studio, but if you've never done it, install Claude CLI and install OpenCode, which is command line, and .NET Conf just this past week, Copilot has in preview a CLI version. And these are very, very interesting because now in our PowerShell scripts or in our even batch scripts, wherever you have a terminal, you can say Copilot -P and a prompt. And you literally can put that in a script file. And same thing with Claude, same thing with OpenCode. OpenCode is the open source one, and you just connect it with your Claude Sonnet 4.5, and it's pretty darn good as well. But now we can put in any kind of script some type of prompt. And certainly, in scripts, repeatable scripts, you don't want large prompts. Those aren't useful. But very small targeted ones where they tend to do a great job. So that would be my tip, is if you haven't, experiment with command line prompts.
For some reason, jumped into my head then about writing that Claude -P for the prompt and telling it to write a script that calls Claude -P, and then you took up recursion before.
Well, actually, I've done that. I used OpenCode, and I had a directory of 10 markdown files with 10 different software features, and I wanted to test these tools. And so the instructions for OpenCode was to go through every markdown file in the order of numbered files and develop them in order and run the build in between each one, do a git commit in between each one, and knowing that the context window is not infinite. So it can't do like 10 features in one pass. And so what I did was I had it use the command line copilot-p and pass in instructions to do each individual feature. So each individual feature was a new session with the Copilot tool, and then the orchestrating session was just looping through files and running the build. And so in that way, we kind of had a resetting or a recycling of the LLM context window so we didn't overflow. But there's a lot of interesting things because everybody is going to be designing a system that can yield software features. And I think it's going to be command line.
That's insane. Oh, we could have a whole episode about CLIs because I've been playing around with Claude Code all this week, which I'm loving, but I'm aware that you are running late for your interview. Before we, so in fact, I've not done my dev tip, have I? So very, very quickly, my one, and I'll include a link in the show notes, is a GitHub project called Awesome Copilot, which I actually mentioned in the architecture meeting we had earlier this week in your architecture forum. I'll put a link in the show notes. It's basically a repository with a whole bunch of instruction files, like AI instruction files for various different languages and tools. There's Playwright stuff and various things like that. It's got an MCP server, so you can use that to add these files to your own project without you having to do it manually. And it's got something called a prompt builder where you tell it your specification and it will talk you through and build your prompt for you and guide you through that. So it's pretty insane. I'll include a link to the show notes. So I know you have to shoot off, but I'll just say a big, massive thank you for joining me on the podcast. It's been an honor having you on.
Oh, my pleasure indeed. Thanks so much for having me.
No problem at all. And a big thank you everyone for listening. A quick reminder that this podcast is sponsored by Everstack, which is my own company providing software development and consultation services. For more information, visit everstack.com. And if you're enjoying the podcast, please do help me spread the word on the socials. I normally use the hashtag unhandledexception, and I can be found on Blue Sky at danclark.com. But the best place to get in touch with me is on Discord. And all the things we mentioned today, including the dev tips and everything, I will put in the show notes, which can be found on unhandledexceptionpodcast.com.